Okay, let's try out problem number 29 here. So this one says you've got these three blocks, you've got the weight of this block and this block, and what's the minimum weight necessary to keep this whole system from sliding if you're given a coefficient of static friction. And then this weight's lifted off, and then you're given a coefficient of kinetic friction, and you're trying to find the acceleration. So I think the best way to tackle this is to just stick all the blocks together. And first, it's maybe helpful to draw free body diagrams individually, and then we can kind of stick them all together. But let's draw these two together since they're stuck together at first. And so we'll just have, that's both blocks A and C together. So when we have this force of gravity down here, this is going to be ma plus mc times g. And then, of course, we're going to have a normal force going this way. We're going to have a tension going this way. And we're going to have a friction force going that way. And then drawing block B, we'll have the force of gravity on this one, which is mbg. And then we're going to have tension going that way. And then, like I said, sticking them all together I think makes kind of sense. So we're trying to make sure really essentially that this friction force is big enough to counteract that gravity, or sorry, this tension over here, but it's connected over here. So this tension is going to depend on the acceleration of this block over here. But if we stick all the blocks together, then we're going to get this whole thing, which has a mass of ma plus, mb plus mc. And the forces that are going to go in this direction is this one right here. So this is mbg. And then going this way, we're going to have two forces. We're going to have a friction force, and then this is this one right here, ma plus mc times g. And we're trying to make sure that all this is balanced so that the acceleration is 0. So that means that I'm going to have mbg equals the force of friction plus ma plus mc times g. I think it's confusing that they had a and b and then c there instead of a and b and c. Anyways, so we're going to try to find out what force of friction is necessary. Now, just to double back a little bit, this normal force we know is also going to equal this whole thing, ma plus mc times g, since those forces have to be balanced out. So this friction force is going to be mu times ma plus ma plus mc times g. Right, so there we go. So we know those things are going to work like that. Okay, so hopefully that wasn't off camera for you all when I was drawing down here. Here's my big block, and here's friction force going this way, ma plus mc times g, and b times g going that way, and then here they are equaling each other. So this has to equal all of this over here. Okay, so let's just stick in now this friction force here, pulling it down there, and then, boy, we're really trying to, the missing piece of information is mc. We don't know what mc is. So all the other ones we can figure out. So let's just write it down here. mbg equals this mess, mu times ma plus mc times g plus ma plus mc times g. And I guess it's just algebra from here, but maybe I'll just factor out this ma plus mc business over here. So mbg equals ma plus mc times mu g plus g. I don't know why. You can solve it however you want to solve it algebraically, but this sort of makes sense to me since I'm trying to solve for mc over here. So maybe I'll just write ma plus mc equals, just pulling that one over, mbg divided by mu g plus g. And then I just have to subtract ma to get this other thing out of it. And everything is given in the problem. I will just caution you though, because it says the block A has a weight of 44 newtons. So A has a weight of 44 newtons. In order to find its mass, we would have to take 44 newtons divided by G to find its mass, MA. Same for M, A, and B. So block B has a mass of 22 newtons. So if I'm finding the mass of B, then it's 22 over G to stick back into this problem over here. Although, having said that, down here I have MBG, so this is already going to be 22 newtons right there. So that's what you're finding. Now, does it say determine the minimum weight? So just being careful right here. If I solve this, this is a number, we know all these numbers. If I solve this for MC, then that's the mass of MC, and now the weight of MC, I have to multiply by G to get the weight of MC. So that's what you're going to do. And then the second part up here, block C is suddenly lifted off. What's the acceleration of the block if the mu k is this over here? So just kind of thinking about everything that's going on, really in this situation over here, if I just redraw this without the C in there. So let's see how we're going to do this. Just give myself some space. So there's that block, and now it's going to be MA plus MB. This side is still going to be MBG. I'm still going to have a friction force on this side, and I'm still going to have a gravity force on this side, but this time it's just MAG because the C mass is missing. This friction force, the gravity force up here on this set of blocks is now, the MC is gone. So the friction force that we were using before, mu times MA times MC, MA plus MC times G, it's just mu MA G. So this is mu MA G. And then I can just set up my net force equation, maybe choosing this as positive again, MBG minus mu MAG minus again, oh, that looks like a mu instead of an M. Let's see, MAG, and this is going to equal MA plus MB times your acceleration, and then you can find the acceleration because all those are kind of given as numbers. Okay, so there we have number 29.